Welcome to the Agile on the Mind podcast, where we discuss how to build intelligent teams inspired by agility and the world of cognitive science. If you're listening to this podcast, there's a good chance you'll enjoy the Agile on the Mind Substack. To receive a free weekly newsletter with explorations of agility and cognitive science, complete with tools, tips and tricks, go to agileonthemind.substack.com and subscribe. This week's episode is sponsored by Embodied Agility. Embodied Agility helps your teams collaborate better by providing training, coaching, and mentoring for your leaders and teams. Wherever your organization is in its life cycle, from startup to supergiant, better collaboration helps you build better products quicker, cheaper, and easier. And Embodied Agility is here to help with that. To book a free 1-hour coaching and exploration session, go to embodiedagility.co.uk. Today's guest on our podcast is Tiani Jones. Tiani has spent over 20 years in engineering and technology. She has a degree in electrical engineering from the Colorado School of Mines, which is a cool name for a school. And she's worked with teams from diverse domains, including mobile applications, IT consulting, flight simulation, aerospace, software localization, and consumer electronics. And we'll hear a bit about those as we go on through our conversation. Her special interests at the moment are Cynefin and complexity, theory of constraints, and flow metrics. Tiani and I met at a conference last year where she gave a talk on patterns and complexity, and we got chatting and struck up a friendship, and we thought it could be fun to record a podcast together and have a conversation that we have ourselves out loud in front of some other people listening through their headphones. When not reading white papers on exogenous and endogenous uncertainties, Tiani enjoys weightlifting, languages, fashion, and art. And welcome, Tiani, to the podcast.
Thank you.
With such a detailed and rich introduction, yes, it's hard to know where to start. But I'm interested, why is it called the Colorado School of Mines?
Oh, I don't know the history of how it was named, but I do know it started out as a mining engineering school sometime in the 1800s. In fact, there's a classic film with John Wayne and I want to say Dean Martin and some other actors. Walter Brennan might be in it. It's a Western. It's called The Sons of Katie Elder, and they're a group of brothers who are outlaws, and their youngest brother wants to join them, hit the road with his on the horses with his brothers, robbing or doing anything. I don't know what I can't remember. I have to watch it again. And they said, no, you're going to make something of yourself. You're going to attend the Colorado School of Mines. And I remember I was actually in school at the time, and I was like, that's very strange and kind of cool. So yes, it's mining engineering, and now it's extended to most engineering disciplines, petroleum, what they call the engineering department, which is civil, mechanical, electrical. I studied electrical and chemical engineering and all those kinds of things, all science, all the time.
So. And something I was really struck by when I saw that talk at the Agile Cambridge conference last year was the way that you come to this work with a sort of scientific, technical engineering background, but not specifically software and not coming from the sort of innovation product engineering. It was very much like hard technical engineering, electrical engineering stuff. What sort of perspectives do you think that gives you in the kind of work you do that may not be as accessible to a Luddite like me that only studied chemistry?
I think it's because I've seen several different kinds of products being built. I've seen various configurations of teams and organizations. I've seen so many different kinds of leaders. My unique experience has been sometimes being the only woman in a department or especially in engineering. I have a funny story about. You asked me about funny stories, and so here's a small one. For example, I was an applications engineer, and most people would hear that if they work in the software world and say, oh, you mean software applications, right? No. It was more of the mechanical engineering discipline where you take a project with certain technical specifications and requirements for performance and what it needs to do and where it's going to be, the location. So, for example, it could be a park that has a pond, and they need to pump water into the pond and keep the water flowing through that pond. They have these pumps that go deep into the ground, and they're actually feeding the pond. Or you have a neighborhood that has a new subdivision going in, and they need to have water pumps installed to get water from the city into the neighborhood, and to be pumping at a certain have a certain level of pressure in the lines and that kind of thing. And so you actually go and design which pumps need to go into the ground, what size, what performance, what configuration, and then what type of controls they need. So that was what I was doing. And then I would go into that same, then I'd go back to a shop floor where they were actually manufacturing the control panel and the pallet that would sit right next to where the pumps were being installed, and that would be all hooked up. And you could go and control the pumps, turn them on and off, and do other things at that panel. So there's a huge manufacturing shop floor. I'd have to go back there. And one day I was I talked to a mechanical design engineer, and I was examining a pallet. And I guess they were more like union workers or hourly workers that were doing the assembly. Someone came over and was like, "Hey, my name is so-and-so, and you're the new administrative ... And I was like, "No, I'm the new engineer." And he was like, "Oh, you're the new engineer. Oh, my goodness. Okay." So, I mean, that's one little small story, but like I've seen all kinds of products being built and working with different people, with not just like, engineers and designers and, your UX person and your tester and your product person kind of thing, but union workers, hourly workers, people that are technicians in various fields. So I think that's given me just ability to understand different domains and an interest for the work, like how work gets done and some of the dynamics that you see in the world of work.
Yeah, I find myself kind of jealous when I hear about people that have done real physical stuff manufacturing, because all the work that I've done has been pretty much with teams doing some kind of knowledge work, some kind of software, some kind of innovation project where there's no physical product at the end. And I imagine when your reference point for what work is includes the physical getting of a pipe out of the pipe machine, I'm sure that's what it's called, right? The pipe machine, down to the place where the pipe has to go and pipe some stuff. You have a different kind of appreciation for what a finished product looks like, for what done looks like, for what quality looks like. Whereas in our software world, these things are a bit more intangible and they're kind of harder to get a grip on. So we need to make them tangible. But if your reference point is, well, it should have something in common with a pipe in that I can see it and understand it and see it being used, you might have a different sort of orientation to how that team works together and how all the other teams work together as well.
Yeah, and I think there's a few themes that come out from that, this idea of workflow. And yes, in some kinds of knowledge work, it's invisible. It's software. It's not hardware. You have people sitting at machines. You can't actually see the thing until you go to another device and use that thing. And even then, it has a different materiality than it does. So I have different appreciation for that, I suppose, and can kind of sometimes see the correlation or draw comparisons in a way, just because of having seen it myself. That helps if I want to create an anecdote or an illustration or a example and go deep dive into it and then tie it back to someone else's context. It's a little easier to do that, I suppose, because I have some things to pull from that I've seen and I've done. Yeah.
Yeah, it's interesting. Like in the Agile world, we're often trying to work out, are we like manufacturing in important ways, or are we not like manufacturing in important ways? And there's always that tension. Well, lots of the practices we use came from Toyota or came from hardware manufacturing where there's sort of fixed outcomes or fixed outputs that look good and we know what that quality is. And then in the software world, well, you've got a bunch of people doing a bunch of value-adding things in an order, but you've also got certain key differences, right? You've got like it's unknown whether the thing that you're making is possible to be produced. You don't know whether it's going to solve the problem. So yeah, I'm interested, like, what, as you've moved into the more, what I would call intangible world of software, what are some of the ways that you had to let go of that material, physical manufacturing, assumptive ways of working? Or maybe not. Maybe it's all the same thing.
Yeah. I toggled between software and hardware work enough that it didn't, I don't know if I ever had to let go of anything, but I did have to learn new ways to get new insights. As I grew and matured in my career, the thing I noticed was from the engineering world, a lot of times we talk about requirements and specifications, and in software, those are needed as well. But sometimes those are treated like we have to be very careful how far we go with requirements and specifications. And we treat them a little bit differently. In software, you might do specification by example in this like language that business people and engineers can understand, or you have just the right amount of specification to get started because the old user story, the 3 C's of user stories: the card, the conversation, and I forgot the third C now. Anyway, I'll remember it.
I've actually never heard of the 3 C's of software. This is a lesson for me. The card,
oh, really?
And the customer.
No.
The constraint.
I want to look it up. No, it's not constraint. It's something actually more. I've given a talk on this before, and it's like so funny how if you don't use something all the time, it goes away from your brain. That's another thing that's like very, the card, the conversation, and the confirmation. So the user story is a promise of a conversation, you would always hear people say. So that ultimately means you write down just enough to get started. And this comes from XP. For
our audience who are non-software people, what is
extreme programming, which is so extreme programming, and if you can just look that up and you'll see a whole way of thinking about how to organize software development, and it includes technical practices and how you describe the work, and one of those things is a user story. Mm-hmm. So you have a physical card, or maybe it's a digital card that says, as a user, blah, blah, blah. And then you have a confirmation, which is like acceptance criteria, maybe a little bit the thing you would test to confirm you did the thing that says in the blah, blah, blah sentence. And then conversation, which is just an implied assumed that you're going to have a conversation and build and like, see, does this work? I think that still exists in the hardware world, but it is a little different because you do have like performance requirements and specifications and some like analysis and simulation you do. So like the talk that you heard me give at Agile Cambridge, there was an actual like, we want to build a different engine fan blade out of a different material. And we know exactly like what kind of plane it's going to go to, what kind of power and electrical and all of the, what it has to hook into. We kind of know all that already. It's kind of just this one piece. Can we swap this out and do this differently? And so there's something different there when we talk about requirements and specifications that is in the tangible world, because there may be some actual thing you have to hook into. But in software, it's like, sometimes you have an idea of what you want, but then you're also, there's such a different level of user interaction, and the user experience is different from software a lot of times. if you're building something that's going to go like, mobile apps, for example, I worked in that on mobile apps quite a bit, where it's like you have to think of all these like design factors about the different device that you're developing on and how it works itself and all those kind of things. There's some different factors there. So there's like an idea of integrating like you would in a system, like this engine fan is integrating into an existing machinery, and you have an app that's going to integrate into an existing, call it machinery. But there's nuances there. So I would say that there's confusion at times in that world of like requirements and specification and what's the right amount to get started and what does it mean to kind of build and learn. And I think that's the thing that where I see most of the swirl happen when we talk between hardware and software products.
Yeah, because it's there's a certain kind of conversation that just happens at the, well, I saw this in Toyota and therefore it's good, right? Or therefore it works. Or I saw this when I was helping a aerospace company build new fan blades and therefore we can apply that to my software world. Even when we say software world, that is an oversimplification, right? Because I could be building software that is very, it's like user-facing, solving a new problem. The design is very important. I don't know if people are going to want this or if
exactly
click all the buttons that I expect. And then I can also build the kind of software that is more like the fan blade, right? We know that people, we have like lots of knowns that are known, and we just want one little component to be like faster or higher performing or more secure.
Yeah, exactly. Right.
Cheaper to run. So when we say like the software world has to be agile and the hardware world has to be
exactly
less, something like these are oversimplifications to the point where you miss important stuff there.
Exactly right. Exactly. Yeah. It's so true. And I've worked on software that was something that no one is ever going to like flight simulator software. It just has to pilots are going to be in the flight simulator and it has to work and feel like they're in an aircraft, but there's absolutely no, you know what you need to do in that case, like all the components of that flight simulator, you know the code, at least you get to know the code. If you don't know, you get to know it. And then you do test, and then you really don't have to worry about the end user per se in some of that flight simulator code. And that's like the back end stuff that I'm talking about, not the front end stuff. So yeah, there's a nuance there. There's this idea of being more context sensitive when having those conversations, and looking kind of like the overarching patterns and the whole context in which you're sitting when deciding what's a good option, or what are the good options for how you can approach problem solving and product development in this case of whatever product it is. So there's more things to take into consideration than just, you saw it happen somewhere. And then, so let's copy paste versus like refer to it and then kind of maybe build off of it and grow it from there.
So let's go a little bit deeper. Like when I'm sitting with a practice that works in one place or a type of product I was building in one context, what are the elements of what makes up the context dependence or the context specificity that makes one pattern of work fundamentally different from another pattern of work, such that I might need to use different practices or have different ways of thinking about it? What's fundamentally different between the fan blade and the phone app for a new, cool, sexy customer experience?
Oh my goodness, that is a very big question, actually. I mean, I can't remember who I was talking with. I think it was Mark Bergauer, who he and Chris McDermott do a lot of work in social practice theory. It's very good work. You should check it out. He once said in a conversation...
This gives me the opportunity to say we will share a link to that in the show notes.
Yes.
I just,
yes.
Very new to this podcasting thing. I get a little kick out of promising to share stuff in the show notes.
Yes. I was having a conversation with Mark at one point, and he said anytime you go into a new context, even if you are going to apply knowledge that you have or you think you know, you go in with a child mind in a way. So if you take that like child mind approach to, okay, I saw something work in an engine fan blade, but now I want to apply it to an app, let's say, for like that specific example. What are the things that are different? Well, there's the materiality, which exerts influence on the people creating and the end user, obviously, and vice versa. There's definitely some of the skills you need, and so that the composition of the team will be different. The workflow, and when I say workflow, I mean the whole value chain is going to be different. Maybe that's because the composition of the team, but more than that, from concept into what they say, concept to cash, that workflow is going to be different. It's going to have completely different elements and maybe different external, what you would say, uncertainties and internal uncertainties because of that different composition of the team. You might even have, this is one of the things that I mentioned in the talk that you heard, is that when you analyze a socio-technical system, so any organization socio-technical because it's like people and technology and machines and physical things and all those things all mixed together trying to do something. You analyze it in three ways, and one was the whole organization, the primary work system, and then the macro-social phenomena. And the macro-social phenomena is the elements such as like, are you working completely remotely? Are you working in a specific geographic location? Have you worked together for a long time? Do you live in a town and live next door to all of the people you work with and have like a social relationship that somehow extends into work and makes work possible? Like, it's like phenomena around like social elements with people that can accelerate and boost and enable work to happen in ways that you can't really understand unless you're actually going and digging and oh wait, I had no idea this connection was here. Or the opposite could be make works very difficult for some reason because of some macro social phenomena at play. So there you go. I mean, that's all I can think of right now in the morning without my tea. Like, so.
Can't wait to find out what you're able to think about in the afternoon when you've had your tea. Wow. So as someone who is entering a space with a new team, you're saying I might consider all those different, so there was the macro social, like what are the ways in which the people interact with each other? There's what's the team that's needed to do this work? There is, and what were some of the other elements? There's like the actual, the materiality. What can you say? You mentioned materiality a couple of times. Can you tell us?
Yeah, the different material. Well, so the engine fan blade, for example, is some kind of actual physical material. It's going to be interacting with a rotor motor engine type thing, and it's a physical good. There is a software, probably some software controls somewhere out. But then in the mobile app example, it's literally in some kind of mobile device. It's an app, and there's the materiality involved in what it means to have a mobile app, that physical and software interface there. I don't know if this interface is the right word, but configuration, what do you want to call it? So yeah, the materiality is just different. It's just a different material, different. It's a different thing. It's interacted with in a completely different way. Its scale is different. And, look at an aircraft and those big fan blades, like versus like a little tiny thing. Like it's a different thing. It's a different thing.
So my question is, like, I might be listening to this and going like, yeah, making a plane is different from making a mobile app. But why is that something that we need people to know about? Like, what are the ways in which people are not realizing that making a mobile app is different from making a plane? What are some of the things that we're seeing that show that confusion?
Maybe by choosing such an extreme example, it's like yes, of course, but I think the point is that when you try to copy paste what other people are doing into a different context, without considering that context in which you're trying to do work or trying to do things, you will have some challenges. It's not fit for purpose.
Because it's something that works well in one place, but
and the thing
within a different setting.
And the thing that we don't often realize is that sometimes those things that worked well emerged over time as adjustments and tweaks and shifts and pivots to suit that context, to suit that problem solving, those people with those skills and those tools at their disposal, and all those factors that some we can't even name at play is what allowed that thing to come into existence that we're looking at now and saying, yeah, I want to use that or try that. It's probably not something that was unboxed. Like, we used to have a joke in this one team where we'd hear people say, just unbox the DevOps. It's like, yeah, like, we don't just go to the store and take DevOps off the shelf. Like, and there's so much emergence that happens when DevOps or we're talking about product development, and that's one element of it, one aspect of it. Things emerge, you change over time, and then and at some point they're observed. And when you observe it at this particular point in time, you're not seeing all that it took to get you there, and all the understanding and brain power and thought and shifts and twists that you did to say, okay, now at this moment, this is how we do things. This suits us for these reasons, and here's why we do it that way.
It's this idea of a sort of cargo cult approach, right? So the cargo cult idea is, and I'm not sure how much of this is sort of based in real stuff versus the kind of anecdote that that gets passed down from agile coach to agile coach for generation to generation. So the idea of, I think it was American aid planes dropping supplies and dropping aid supplies off to sort of distant, remote tribes. And then, so they would get these sort of big boxes from the sky. And then one day when the anthropologists finally made contact with some of these people, they realized that a lot of their symbolism for what a god was or what the world was emphasized through these planes and through the boxes and things like that. They had these like effigies of a plane because for them, it was a sort of misattribution maybe of cause and effect. Although I'm arguing with that in my mind. It's like if I get the thing from the plane, then the plane is a kind of god. It is providing in a certain kind of way. But I think the lesson that I take from that cargo cult story is, well, if you start like worshipping the plane, then you think the plane has powers that it doesn't, right? And equally, if I start worshipping, I guess in our example, it's the making of the plane.
The making of the plane.
Yeah, and the kind of patterns and practices and whatever technologies, approaches, theories that help me make the plane. I start worshipping those. Then I start applying them in the wrong place. And I start thinking, this is how we get shit done. And actually, the shit that you get done when you're making a plane is, in very important ways, different from the kind of shit you get done when you're doing lots of other kinds of work. So maybe there are things that you can take and you can learn lessons, but also maybe not. And I'm curious. I'm curious how patterns fit into this, because that was the main topic that we sort of spoke about in Cambridge. So what is a pattern and how does it fit into this conversation?
So it's interesting because I was just about to say the pattern is the thing you might be able to use, because then you're still, it's almost like if you take if you go to the fabric store and you find a pattern on, you still have to like choose so many things in order to recreate that garment. It kind of gives you a guide for being able to recreate the garment, but you're still going to make your own garment with its own, to your own taste and to what you need it for and where you're going to wear it and all those kinds of things. So in terms of organizational patterns, which is what I was talking about in my talk, is we see them all over. And I haven't I could probably give you I could probably look up like a dictionary definition for a pattern, but this is the way I usually talk about them. And it's not like a very streamlined definition, but hopefully it helps people understand.
Those definitions very welcome.
Okay, so I often use I use Westrom's typology a lot of times as a guide for this conversation. So Dr. Westrom has, I think it's Ron Westrom, he has 3 organizational culture types that another opportunity to share a link, I suppose, that he describes, which are pathological, bureaucratic, and then generative. And the reason why I like this because it's everyone can kind of understand. And lots of people complain about bureaucracy or pathological cultures or things like that. So they're easy for people to say, oh, yes, I understand that. And those are considered kind of like organizational behaviors.
Can you give us an example of like a bit of shape to what those different typologies might involve, just in case someone isn't familiar with what the elements of a bureaucratic or a pathological organization might be?
Yeah. So I'm going to actually pull it up because I want to say exactly my examples. So then there's a couple that the couple of 3 themes, which are like pathological, bureaucratic, and generative. So things you would see happening if you behave in a pathological or behave in a bureaucratic way or behave in a generative way. I'll give you one example. Bridging is a term that he uses. What is bridging? Bridging is, walking over or slacking people from different departments, different teams to share knowledge, messaging. Yeah. Kind of, I just made up word. So messaging or getting out, walking, and hey, how did you do that thing? Or hey, do you know how to do such and such? We talked about is it the water cooler in the break room or whatever, and how is it going today? And could you help me with this? And that's bridging. The pattern that you would see is the thing that repeats and is repeatable throughout an organization and traceable to the behavior. So when it comes to a pathological organization, it's power-centered. And so bridging is often discouraged. It's like stay in your lane, and you have to get lots of permission to talk with different people and work with different people. You need to really be careful. In a bureaucratic organization, bridging is tolerated. It could be a bit annoying, but where rule centered is, but if the rules haven't been broken, who it's fine, that kind of thing. And then in a generative organization, bridging is encouraged because you need to share information, you need to share knowledge, you need to build that muscle and build that ability to jump in wherever you can with whomever to get the work done. And that's more important is the mission. The mission is more important. So anything that aids that mission in terms of collaboration, bridging, sharing is great. It's encouraged, actively encouraged. So the pattern there is squashing or actively discouraging, squashing, bridging, not tolerating it, or encouraging it. So that's one pattern that you might see. So he describes other patterns that you see repeat in organizations that tend towards those behaviors. And of course, we know because of complexity, they have combinations of those behaviors most of the time.
So if we go back to our earlier question, which is, what is the fundamental difference between designing, what are the fundamental differences about designing a fan blade that plugs into a plane versus building some software, and how might I be able to take lessons from someone working in a very different socio-technical and material context and apply them to my own socio-technical, macro-cultural, technical, material context? The answer to that might lie in patterns. Like, I don't want to do exactly what you do, but I might want to factor out the patterns that make your thing possible and see if they're appropriate to me. Is that a fair articulation?
Yeah. I mean, because I've worked so... Funny you should ask. I have a specific example. which was one that I gave in the talk, but it was about literally the engine fan blade. So it was a team of rocket scientists. And the thing that I observed, so that was kind of my job, was just kind of moving constraints around a little bit to make something possible that wasn't possible before. And in this case, one of the big ones was that of the 4 or 5 engineers, rocket scientists working on this project, they'd done some simulations and they pulled the team together. And what we learned was, what I explained to them is, do you often just like take your little piece and then send it off? You get something from someone, you do your piece to it, and then you send it off. And they were like, yeah, that's pretty much kind of assembly line, just, an assembly line approach. So when I asked them, I said, are there certain points along the design process and in this, like, you're going to actually manufacture it now, where you could actually work together and not just parallelize, but like literally sit together and collapse something into one? They're like, yeah, I think maybe. I said, okay, so look for any of those. At any time an opportunity comes up where you can do that, just do it and try that. So they did it. So rather than doing, I get something, I do my bit, hand it off, they now said, hey, for this thing that's coming up, let's all sit in the room and like work together on it. Or you two go pair off and do that. And so you may have a systems mechanical engineer or electrical engineer and mechanical engineer now sharing work. And we talk about that when we talk about cross-functional teams. We talk about that pair programming and even designer and developer pairing in software world. So why can't we do something that didn't call it pairing, didn't call it pair programming? I just said, look for opportunities to work together where you would typically hand something off instead. So same thing, roughly, different materiality, different skills at play, different product in development. The concept is we're going to co-design, co-create, literally like 2 people or more together at the same time doing something. And there's going to be conversation and dialogue and tinkering with something, and it will produce something more effectively. In theory, it will, and it usually does.
Is co-designing and co-development always better than someone going off and doing their thing by themselves?
I don't know the answer to that, except what I would say is that you have to also take individuals into account and their needs at times. So I did work in an environment that was all pairing all the time. And for some, maybe if you tend to be more introverted and need a little bit of like quiet, refresh time, and then you're fine with, obviously introverts are I'm one, so I know I'm fine with conversation and interaction. I love it. But sometimes I might need a minute, or I get a bit tired if I've been talking for a long time, or I'm over processing, overstimulated by everything, and I need a minute. And I remember seeing someone who needed to go in the corner with the noise canceling headset and needed a little bit of time every day to do that for their creative process to feel okay, and at the same time do co-creation in other parts of the day. And because the environment tended towards all pairing all the time, it was then looked upon as like bad teaming, because it's like, but this person has needs that are not being met by the pairing all the time. So I would say that's one factor to take into consideration and just be sensitive to. The other thing I would say is that it's good to have flexibility towards the context. And so if that means you need to learn a lot, you need to, in those unknown, when you said there's lots of, like, some projects have more unknown unknowns kind of, or known unknowns kind of thing, and you need to increase the amount of learning, I think it helps to actually have more co-creation and something that is very much a plug and play, a simple task, less learning involved, a little bit more repetitive. You probably don't need people to pair up per se, unless you're like teaching. But then again, let me give you an example. With the fan blade team, there was one person in the whole facility that knew how to do the lab setup. There's no fancy discovery or innovation happening there. It's literally practically, how do you set this lab up so that it's safe and then it functions? And it's a lab that has a giant aircraft, like motor kind of thing. And that person had other work to do, but was always, you couldn't get time with him for like a month. So they had one person from this fan blade team follow them around and document in detail every step they did, cleaned it up, had them review it. They said, yes, that's if you follow these, you've done it right, it's safe. They published it for other people to use it then. So there's something about good documentation culture, other ways of doing knowledge sharing that allow work to be done, and not just the pairing up and the learning through code design, code development, like sitting in a mob development kind of thing. There's a few ways I think that enable work, that make knowledge, that capture knowledge and allow you to transfer knowledge and share knowledge. So I just think analyzing what you need in a given moment and what makes sense in that context is the way forward. So no, it's not necessarily always needed or always the right way, always better. It just depends. But if you're talking about lots of high learning, discovery kinds of work, then yeah, I think it's usually, I've seen it work much more effectively than the handoff approach.
Yeah, it's such an interesting topic, and I in my experience with teams, there's some of the most interesting conversations we have as teams are when we try to navigate, like, how exactly do we tune this? Because when I say to my teams, pair programming is, roughly speaking, most of the time better. So we should try and do more of it, right? And we don't have code reviews where, I do some work and then you check it and then you send it back to me and then I do it again. But we say, we're just going to pair program. We will correct each other in real time. And then by the time we're done, like, the thing is ready to go. And we have systems and scaffolding in place that means that that's safe. And in the technology world, that would be like automated testing or whatever. But let's stop talking about software. Let's talk about a medical setting or a surgery or a theater or something like that, where there's the example of when they're going to amputate a leg and they sort of draw the cross on, and there's all these scenarios that happen. I think it's in Matthew Syed's the black box or black box thinking, where sometimes you got a situation where the head surgeon crosses the leg and everyone else in the room is like, I think it's the other leg, man. But they don't say it. And then, that's a situation where you have the knowledge of the problem in the room, but it's not evenly distributed and it's not all being shared. So a bunch of people are thinking there might be a problem here, or I know something. I remember reading right leg and you've just crossed the left leg.
Yeah.
Okay. So that's a kind of collaboration that you need, right? I've got the information you need, and it's better that we do the work at the same time. We all ask the question in that operating theatre, which leg is it again? And sort of creating the conditions for that. So that's the example of the safety setup person and the person shadowing them round, right? There wasn't anything fundamentally collaborative about them looking at this problem together. Just this person had information that was a kind of constraint on what work we can do, and they became the bottleneck, and now we can't do anything until this person is free, and they're really the only person that knows it. So let's get some of that information and share it. So that's kind of a knowledge point of view. Then there's the other one, which is like a perspective point of view. So let's say there is, let's go back to the medical theatre setting, or maybe some of the people you worked with in the rocket scientists, or the mathematician, the theoretical, I don't know, the guy who's interested in the physics, or the woman who's interested in the physics. And it's interesting that my language associated there. Maybe that was anchored by your mentioning earlier that you're often the women in these teams. Just catching myself doing that and verbalizing it. the person who does the maths might have a different perspective on a problem from the person who's thinking about the safety, from the person who's thinking about some other element. And it's not a question of like knowledge that's in their head, it's a perspective on a problem. So we see that in software when you want to get the quality assurance people, like, how do I break this thing? In the room with the engineers, how do I build this thing? And between them work out a plan. And that's a different pattern, I guess, of collaboration to the I'm holding on to some knowledge and I should share it with you. And then there's this like practical one, which is, as you mentioned, the introverts don't want to spend all day with people. And when I say to my teams, software programming, pair programming is roughly better, they hear, you're going to make me sit with someone for 8 hours a day, and I don't like that. And some of these most productive conversations that we've had, and I'll stop talking soon, are when we fine-tune the conversation, where we go, no, let's just, what if we say, like, we default towards pair programming? What would you need to make that safe, healthy, and enjoyable? And they go, well, we're not going to do it for like 2.5 hours, no matter what. We can take breaks, right? I'm like, obviously, if you need to, yeah, you can just take a break. You can say, can I have 5 minutes, go get a cup of tea? And they're like, oh, okay. But there's a kind of, I don't know, agile collaboration orthodoxy, which just assumes that you should sort of be in groups all the time. That doesn't work for people. And then people read into that kind of language stuff that they're actually quite threatening to them. Like, you, introvert, have to spend all day with me, extrovert. You better enjoy it. Otherwise, you're going to get marked down on your performance review for not being collaborative enough. Yeah. And that's, so we need to find more intelligent ways of, I think that's where that original question
or else, right.
Is it always better? Because there's maybe I'm sense this assumption that together is always better, and then there's a pushback, and we go, in which case we don't want to be agile because we don't want to work together all the time. Sometimes it's better for me to go read the documentation and tell you what I learned. And true agility in my mind, would be creating room for that, where we go, obviously if you need to go off by yourself, just do it.
Yes, absolutely.
I'm interested to move on to complexity, which we've mentioned, we've brushed against complexity, but I know it's an interest of yours. And what is complexity? How does it relate to what we're talking about here?
So in terms of if we're talking, because that's the work that you and I do, is working in organizations with people building things. So these are systems. And systems are a collection of, they're a function of interactions. And because of the human factor, they're not always predictable. There's lots of things you can't predict, and there's emergence. Things emerge, things change, and things come out of those interactions in the system that you're like, that's interesting. I did not know that was going to happen. And that's roughly how complexity manifests itself.
So if I've got a system, so lots of different parts all interacting with each other in ways that are impossible to predict exactly what's going to happen between all those interactions, but something stable emerges from it, that's complexity?
Something stable emerges?
Maybe I put my own lens on that. Like, I see those when something emerges, right? So let's find an example. Let's say, like, is an orchestra a complex system? You think you've got lots of different instruments, or a jazz ensemble or something, where they're each playing and interacting with each other and making eye contact, and the sound that emerges from a jazz orchestra is not just the sum of its parts, it's something extra.
Yeah, I mean, especially if you're talking
Tell me I'm happy to be wrong.
Well, yes, you're right. And especially if that jazz orchestra is on a stage or with an audience, and every night they do this, the audience changes. That's 100% complexity at play. And the thing that I think is, or one way I like to think about this, or have talked with different people around complexity, is this idea of, if you go from, I think I may have heard this from where did I hear this? When you've been working or studying complexity for a long time, you start to forget who said what or where you learned something. But I remember someone just...
Forgetting an emergent property.
Yeah. I remember probably. Someone said that if you go in a complex adaptive system, which is most, a people system can be considered a complex adaptive system, you could say that we as humans add a special layer of complexity called anthrocomplexity, because there are complex adaptive systems in nature that are not human, like an anthill or a beehive. There's complexity there, but as humans, we are very special in some ways. And so the complexity is this idea that if you go from A to B, you might not be able to get back to A, but if you do, you'll never get back to B again because conditions have changed already. And then I know there's different schools of thought, I guess, in complexity, and the soft systems is one of the schools of thought, like Peter Checklin's soft systems methodology. I heard about this very early in my journey into my deep dive into all things complexity, and he made a very simple distinction between a hard system, which could be a feedback control system, your thermostat system that controls a building, versus that controls the temperature in a building, versus anything where you've introduced people, a football game, a chess game, healthcare, and the jazz band, jazz orchestra, anything with the people element inserted into the system, doing things together, now becomes a soft system and therefore complex.
So that's interesting. So when this is going to take us to the fourth C of this. We had card, conversation, and confirmation. Now we're going to talk about Cynefin, which is Dave Snowden's sense-making tool.
Yes.
About complicated type problems, complex problems, clear and chaotic, and them having all these different domains. And the way I always teach it when I bring it to a client is I teach chess as an example of a complicated problem, because there are fixed degrees of freedom, as in you can't make any move on a chessboard. There's certain very hard governing constraints, rules of the chessboard, and the numbers of squares on the board and which pieces you have. And within that, you can get lots of different combinations. But in theory, you could sit down with a long enough piece of paper and calculate every chess combination. It would just be like 6 with 10 to the 10 tens after it or something.
Mm-hmm.
It would just be some huge number. But it is, there's no unknowable chess move. So according to that definition, though, you're saying because there's a human involved, even a chess game would be complex in some way.
I mean, how many times have you seen a chess players, watching the body language of the other person, or maybe seeing if they could do something that would literally unnerve the other person? Those are the complexity elements, like the game, the board itself, the materiality of the board and the pieces and the moves that you can make are perhaps not complex because I don't know. Are the moves that are named after famous players, which I'm forgetting them, the French defense or I don't know.
Was there a famous chess player called French defense?
No, but they'll say there's the French something or the Italian version of a move, and then there's someone's name, and I'm like, oh,
there's the blah 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 variation, the knight.
Yeah, is that an emergent? That maybe you could say that something emerged, like a combination, and it seemed to be successful, and they won some great tournaments out of that. I don't know. But I would say that the rules of how you play is on the more complicated side. But if I know all, this is a point I make in my talk, in fact, is that if I know the rules of chess, I know how to move the pieces, it doesn't mean I'm a good player. There's something else about knowing how to create opportunity and sense it, or calculate it, or think ahead, or respond to what the other person's doing. And once you begin talking about those kinds of elements of the game, there's complexity there, because you're not quite sure. And there's things at play. There's I watched a tournament with Magnus got food poisoning, and he kept saying it's put him off his game. He ended up winning, but still he didn't look very good. He was really struggling, and who knows what might have been differently had he not got food poisoning. Things like that. There's like human element. There's illness. There's, the room's too hot. The room's too cold, and it's bothering me. And someone walked in to my right, and I need in spot, and now I'm distracted. I don't know. That's complexity.
It's buzzing noise coming from my opponent.
Yeah. They're cheating.
That's really interesting. Yeah. There's a really interesting, I love that actually, because it's chess. Yeah. Chess by itself, chess as two computers playing chess, or chess as just the rules themselves. Yeah. Not a complex problem. It's not unpredictable, but you can't realistically abstract those things away. So when I play chess, it's all of a sudden a complex scenario, because you're right. Like, I play chess differently against you, when I'm terrified of, because you always seem to beat me, versus when I play someone that is 300 points less than me on 600 points. And then I may be a bit more careless, or a bit more, maybe more creative. I don't know. But you can't abstract the human away from the technical thing, and in this case the technical thing is the chess. And that again zooms us back to the conversation we were having earlier, which is, though your team is building software, aerospace stuff, fan blades, doing a surgical incision, whatever, the whole problem is being solved by this socio-technical system, which is by definition a complex one, because it has the unpredictability and the interactions of the humans there, and therefore you need to treat it with the ways that you treat a complex problem, and not treat it like it's an abstract maths only problem.
Yeah.
Maybe you'd argue even maths is a socio-technical system, because you've got the mathematician in the room, and maybe that again is an element that's worth thinking about.
I mean, it's kind of a tool. I think math is a in the human's hands, a tool to do something, and now you're in socio-technical complexity land, and you've picked up your tool, and now you're doing things with people. And when it's in the toolbox, sitting there in the toolbox, just it's different than when it's actually in use.
Which I guess is why as Agilists we tend towards the more collaboration, treat this thing as if it needs lots of perspectives side of the equation as a default until shown otherwise, right? Because even a chess game has a socio-technical element to it. That means that I need more eyes on this problem, because it's not a known fixed shaped problem.
Right.
It's a softer, emerging, changing, complex problem where you can never get in the same river twice, and point A, point B, point A won't be there the same way you left it, and therefore we default to lots of perspectives and a kind of, I wrote a blog about this last week, like resilience over efficiency. So lots of people collaborating on something is like a resilient pattern. Sure, it's not efficient, because all of those people, if we had a completely perfectly cut out problem, they could each go by themselves and solve it in exactly the known way. But we very rarely have fully known problems in our world, and therefore you're often better to start with resilience and then work your way into efficiency.
Yeah, I think another way I've heard it spoken of is effectiveness over efficiency. So figuring out what is the effective way to work, and or effective way to configure things, configure yourselves, is where you start, because in order to enable the flow of value, enable the production of value, enable learning, those are the things you need to consider first. And then once you understand that, and you've practiced that and you've learned some things in your context, then you can start to say, how might we make this more efficient then? Because to start with efficiency could be building the complete wrong thing, or doing the wrong thing, doing something that's completely off base, but doing it in an efficient way, whatever efficiency means in terms of the measures that you're applying towards that. So yeah, I definitely believe that in most cases it makes sense, or in many cases it makes sense to start with what's effective and then talk about efficiency. Yeah.
It comes in when we're thinking about like busy work or busyness. If you have a team where everyone is fully, quote unquote, utilized, like everyone is sitting and working for every hour of the working day, that is a kind of optimization for efficiency, but it probably isn't very effective, because actually then they're not free to collaborate with each other, and the problem space that you're in probably needs free time to collaborate. So by being fully busy, you're not able to improve, you're not able to ask if there's better ways of solving the problem, you're not able to ask where your blind spots are.
Yeah, you have low capacity in that case, and the capacity is kind of the currency that you pay, that you need to have available to pay. There was something you just said about being busy that I thought was interesting or sparked a thought. I've seen teams and organizations say, yes, we want to do that, but then they've got, especially when you talk about organizations that are conglomerates or large scale, like, thousands of people, I've often seen with a couple of teams I've worked with that if you look at how they do their funding and their finance, and then how they staff projects is driven by that. Sometimes you see some weird patterns there where you create conditions for like low capacity, and you just, unless you go to that, the main constraint at play, you're just never going to get a solution to that. And it's almost like you have to descale that organization in a way to solve that problem. And low capacity, I find, is such a problem to, and such a blocker to so many things that you just described so well. From the individual being able to have space for reflection and or rest and or stepping back, for the team, and I call it like the pizza-sized team. Pizza-sized team, enough people to share a pizza and everyone gets enough. I can't remember where it comes from. Like, isn't it Dunbar's number? Or
I think the pizza-sized team is like, how big should my scrum team be? Enough that you can have 2 pizzas serve everyone. Dunbar's number is like 120 or 150. It's like the most number of people we can keep in our social sphere. Which
exactly.
Everyone gets a slice of one pizza.
They don't. So I'm not talking about a team of that size. I'm talking about literally like 5 or 6 people, having capacity to try and test different ways to work and tweak and all that stuff and learning about what it is that you have to produce, to the teams of teams, to the organizational level. Like, low capacity it's a killer. In terms of enabling those things that we talk about are good things that you need to be able to build or develop or produce or work in whatever domain effectively. So, yeah. I don't know where I was going with that, but it's just an observation.
It goes to this really like human experience that when you ask people like, how's work? And they're like, I'm super busy. It's very, for some people, it's like, yeah, I like it. And maybe for them, all the problems are lining up in exactly the right way, that like busyness and effectiveness are aligned, right? The problem is they know the shape of the problem they're dealing with.
Right.
Because my busyness is an efficient way of solving all the problems I have.
Yeah.
But most of the time when people are like crazy busy at work and then something else gets thrown on your plate and you have to rejuggle, or you drop something, or you disappoint someone, or you don't have time to ask yourself or the team, how could I be doing this better? that's a real performance disadvantage. And if I think about, I don't know, managers of organizations or people who are setting up their own companies or whatever, and they're thinking about how do we use everyone's time well, the right amount of flexibility is absolutely key. If you don't have that, then you can't change your plan at all. You can't reprioritize at all. It becomes really painful. And then that goes to a human experience of being overburdened, overworked. Your cognitive load is stretched in a million different directions. And before you know it, if you scale that up and everyone's experiencing that, well, then how can you expect the whole team to be working really effectively together? And if we think of our examples of the best teams that work the most effectively, I don't think of like a football or a soccer team. They're not like texting as well and trying to like order their lunch. They are focused on winning the game, and they are in that domain fully. If you think about Magnus Carlsen, when he's not trying to avoid throwing up at the chess table, he is in the game solving that problem as well, and like creating the space where that is entirely possible. And if we think of those as the archetypes of our teams, not like a feature factory that can get through like a million story points or whatever, and just churn through lots and lots and lots and lots of work, we ram more work into them and just get them really fully utilized, well, then I think that changes. That's a big lever that changes a lot of the assumptions about how we could run an organization.
Yeah, that's true. Yep.
So going away from the more sort of theoretical level and down into maybe the more practical level. So we know that we've got this constant tug of war maybe between effectiveness and efficiency, or resilience and efficiency, between like known problems and unknown problems, which kind of patterns and things you utilize, you use to optimize for the kind of problems you have in front of you.
Right.
What are some of the tools and the techniques and the practices that you use in your work that can span any kind of problem that you're dealing with, that are useful even in a very unknown team or a team that has lots of knowns?
Techniques that can span any of those situations,
or at least that tend to be multi-tool, multi-application tools that you have in your toolbox. I know we've spoken about theory of constraints and Wardley mapping.
Yeah, some of the tools that I would say I like to use are, well, those are two. Theory of constraints would be something like the current reality tree and future reality tree. I haven't been able to get to a future reality tree very often, but the current, just because of the...
So let's assume I know nothing. What is a current and a future reality tree? What are those things?
So
when would I use them?
It's an exercise. So this is like a very good one to talk about, since we just came from the topic of complexity. And I actually went to a masterclass in Chicago. It was in 2019, I think. Yes. On the theory of constraints and Cynefin. So Dave Snowden and Steve Holt together, and some other experts in theory of constraints and in complexity, were in the room. Kind of, being that it was a masterclass, they were tossing around ideas and kind of developing what their theory, quote unquote, is of how these work together. And the reason why that's of note is that in the theory of constraints, you're looking at a system, and if you're talking about the current reality tree, to paint a picture through small cause and effect linkages, like if A and B, then C would happen. These two conditions, when they exist together, then C happens, and so on until you paint this tree that hopefully identifies the main constraint, the constraint, and we know you want to go to the constraint, and the constraint is like the main limiting factor that's happening, the limiting
constraint, the rate limiting step,
the thing that's like, if you do some if you make some change here at that point, it will have an impact that branches out through the branches of the trees. It's more impactful than doing little optimizations along this whole situation. You've actually found the thing that's causing most of the churn or most of the difficulty or that needs the most attention in whatever you're trying to do. And so now in complexity, we often say that so much of the system is not knowable, but there are certain elements that are knowable, especially in a large system that you for example, we talked about the funding model. If you took that funding model and describe it to me, the one we talked about where people are kind of have to be on a project, or maybe they have codes that say this is the project you're on, and they're and sometimes there's they're on 4 projects, so there's 4 different codes and they have to manually enter time against those, or I've seen things like this before. And so therefore they probably have low capacity. You're probably you can understand that and say, this is what I'm probably going to see these things happening in the organization and these challenges, and you're probably going to be right. So you can know some things at the high level, at certain levels.
Those are fun customer conversations where you hear a couple of things and you go, am I right that you're also experiencing this? And they go, yeah. You're nice.
Right. So I say that I like to use that tool because it's not that you will know every single thing that's going on in the system. And, if you take too long to make your tree, conditions could change. I've seen it happen where the team had low capacity. We started making a tree. We got some insights that were quite useful. And then the conditions changed. What were the conditions? That team was disbanded.
Yeah.
And the whole thing went away. So it was start somewhere else or moving on to the next team. So that's a factor, which could we have known? They didn't really know that was going to happen. At some point they had inkling that it was, but there was a point where they had no inkling that was going to happen. They were making a plan for the next 12 months. So I don't know why.
Well, I'm interested. How do I make one of these trees? I'm in a team. Let's think of a more simple example. I don't know. I'm working in a restaurant, and I don't know. There's a waiter and a maitre d' and a chef or something. How would one of these trees be constructed in that kind of context? And then we can look at how do we find the constraints. So
the way I've started with this, and there was a friend of mine, his name is Simon Copsey. I don't know if he's ever going to listen to this, but I'm going to shout him out. Simon, he's been giving lots of talks about how he's helped different teams and he's using these techniques coming from the logical thinking process. It's a really good book. So he helped me. He shared with me a workshop style that he had kind of put together, and I've been following that flow. And it's been pretty useful. So we start off talking about what are the undesirable effects. And
so in my restaurant, what might that look like?
What are the undesirable effects? So customers getting their food late, or it's cold, or customers sending back plates because the order was not correct, or some quality issues with it. And unable... the restaurant's having difficulty with maybe, the wait time is too long for a table, and there's a mismatch between when you get a reservation, and it's hard to get a reservation, and then when you do get one, you still wait for a long time, something like that, maybe. Okay. Undesirable effects. And so you take those and then you say, what are some things that could be contributing factors to those? Let's call them causes to those effects.
So you're getting the wrong order because the waiter or the waitress is writing down the wrong order.
Yeah.
Or because the kitchen staff are too busy, so they don't read the order.
Yeah. Yes. And then you kind of use almost like a 5 whys technique. So why are they getting the wrong order? And then we can't find pencils to write them down or something. Why can't you get pencils to write down orders, or what's, whatever. So you kind of go back until you get to where you can't go any further. And then you string that all together. And then you see, oh, wait, it's actually this thing here with how we set up plan our day for the restaurant or something like that. If we work on that, it's going to, I think it'll alleviate all of these things, because this is the pivotal, impactful point. impact point right here. It allows you to visualize it in a way that everyone can understand it, and everyone can look at it from their different angles of those. So if you're talking for the people in the kitchen, the people in the front of house, the wait staff, the person who greets at the front, at the maitre d', or the not concierge, maitre d', I think, at the host, the wait staff, the bus people, bus boys, whatever you call them, like the people who wash dishes in the back, the chef, the sous chefs, like all of those people can like look at that map and have a contribute to it, and they can get a very nice picture of what's going on. I'm sure there's nuance that you can't cover when it's in terms of complexity, but at a given night, you could analyze what happened and maybe some conditions that are existing and ongoing. And therefore, it gives you a better starting point to tackling your problems, to coming up with potential solutions, to coming up with some experiments as a team to improve the organization.
I like that because it takes, I've used 5 whys with my team. So 5 whys is where you say, something happened that we didn't like. Why did that happen? Why did that happen?
Mm-hmm.
If you ask it 5 times or 9 times or whatever, you get back to like a root cause. Problem is, in a complex world, there is no root cause. There's lots of root causes.
Lots of them.
Constraints. There's constraints and there's emergent stuff, and the emergent stuff was stuff you didn't like, and you can't, why did this order go wrong? Well, because physics interacts in such a way that like plus and minus are attracted to each other, and that created all the conditions where all these other things were possible.
Yeah.
So that's not a useful affordance as we would maybe use in systems thinking or language. Yeah, that's not a useful lever that I can pull. Changing the plus.
It doesn't make physics. Yeah, you can't. It's just not an affordance. Yeah.
Yeah, but what I can do is I can say, well, what looks like it is and that's why it's nice to have theory of constraints in here. What are the points that everything sort of goes back to?
Yes.
And then let's try something. And I don't know that adding pencils to the to the roster, to the bucket of pencils is going to solve all these problems, but it might, and it looks like it's our best guess right now. So as long as we treat those things like a guess or like an experiment, and we try something and then we reflect and we come back and we say, did adding loads of pencils help? And then with a genuine curiosity that it's like, well, actually, no, it didn't help, because what that meant was that now, we've some other unexpected problem, and now we need to solve that, and we do the whole exercise again until we get the kind of outcome that we want. As opposed to like the root cause analysis type thinking is like, no, it's pencils. Fix the pencils, fix the problem.
Yeah.
I don't want to look at this again. It could encourage that kind of thinking.
Yeah, exactly right. So it's logical. That's why it's called the Detmer's book, The Logical Thinking Process. Is a great one to read if you want to understand how to use this tool. So I like that one. I also like anything like value stream mapping, or I've been trying, so there's the new book coming out by Steve Pereira, and I forgot his co-author. I'm very sorry. But the book is called Flow Engineering. It's called Flow Engineering. It's going to be coming out in May, and I've been trying out some of those techniques. But it's basically, I've done value stream mapping before, where you kind of take from the beginning to the end, like a whole process, and map it out, how long things take, the different steps, how long you wait in between, all that kind of thing. Using it more as a qualitative versus quantitative, more of like getting a sense of sequencing and a sense of, what data is available for how long things took, or when things looped back, or where there was waste or duplication. And then a series of conversations you have about how you can then improve your flow. I really love that technique. It's great. That one's kind of relatively new. It's kind of an add-on to like value stream mapping, which I've done before. Wardley mapping. There's like a mapping theme here, which is funny because my father was a cartographer, and I used to love to hang out in his map making office. So now I make all these other kinds of maps. It's very strange, but anyway.
Business.
Yeah. So Wardley mapping I like for strategic intent, and because it takes into consideration complexity and the different, what's fit for purpose given your particular situation. So are you building something that's brand new, or you're just testing with a new material that could turn into a product, and it's like give us an overview of like
who would use Wardley mapping? What problem are they trying to solve with it?
I think Wardley mapping can be useful to anyone that has to work on strategy, but I think it's the most useful if you happen to be someone who's thinking more long-term strategy for an organization. So more at the the head, that's going to steer the whole ship for an organization. I think it's most useful there, but the thinking tools that are involved, I think, are useful for anyone that has to do any kind of execution and deployment of strategy, or thinking through strategy and understanding what good options are. So it starts with a landscape, and that landscape, it was ultimately designed as an explanation for how capitalism works, of how business works, and what happens when a product or an idea comes into existence and then it moves along and matures and becomes a commodity. So it starts with this idea of a genesis. Like, for example, there was in that research center that had the fan blade out of a new material, there was this idea. I think they had discovered some new rubber compound, but that was eventually going to become like an aircraft tire, for example. So that new compound, it's like in its genesis state. It's like we're trying to figure it out. We don't know much, or we learned a little bit, and it could give us competitive advantage if we make the best, most durable aircraft tire. I don't know, that kind of concept. And then as you begin to develop that product, it moves into more like a custom built. And then from there, it moves into more like productized. It's like it's gaining market, people, it's in use, it's being sold. And eventually it may stay there, or it may mature all the way to a commodity, which is like on the commodity side of this landscape that's the land of making things very, very efficient, we talked about earlier. But on the other end of the landscape, that genesis, new idea, innovation, that's like the build and test and learn and like discover kind of end of the spectrum. And then that's kind of like the horizontal view. And then the vertical view of this landscape is everything's tied to a need. So whose needs are you serving? Who has a need? And then what enables those needs? So that's how you end up creating this map, is like anchoring to a customer or a user, their needs, what enables the needs, and then horizontally, where do those things lie? And then you can figure out what to do from there.
So how does that y-axis work? Like, well, what's high up on the y-axis?
What's very visible to the end user or customer versus not visible, and that's very much at the bottom of that. Yeah. And the reason why that's good is it's a thinking tool. What I like is the traceability. So all these enabling projects that you might do, or projects that have, pulling something that's like a commodity versus making a project or a product out of something that's like in this genesis idea, you can visualize now how it all connects. There's traceability. That's really important, I think, in strategy work, is the fact that you're making trade-offs and you have options. And it's good to have traceability of the options you select back to like your purpose and like the reason why you're doing it, and be able to have something you can refer to back and understand and reason on. So that's what I like for that.
So if I'm a restaurant, for example, I'm thinking like, how would I map the things that are most visible to the user? Might be the recipe or something. So that would be that might be custom, or if I'm doing some sort of genesis, some new fancy thing with foamed fish, maybe that is in like genesis mode. And if I'm doing like something interesting and different, that would be in the custom mode.
Yeah.
If I'm making burgers for everyone, but like roughly the same, they're just good, then they're in production. And if I'm just opening a McDonald's, then I'm in commodity, maybe something like that.
Maybe, yeah. There's the very little that's customized. It's kind of it's kind of like that's an unbox the McDonald's kind of. When we talked about unboxing the DevOps, like let's unbox the McDonald's.
Unbox the McDonald's frog.
Yeah, yeah.
And like I think the example, when I think of Wardley mapping, I think of like where does where does electricity fit into this? Right, there was one day where electricity was this exciting, new, shiny thing that whoever had electricity could do. It was just like completely unknown what you could do with it, and then it became like, well, we can customize particular uses of electricity, and then it became like production. Well, actually, there's lots of light bulbs and stuff around, and eventually it just becomes a commodity that is no company is, other than the electricity generating companies, are there saying, why don't we like come up with a new way of generating electricity so that we can run a drill shop? Like, no, it's a commodity. You get someone else to provide you the electricity because they can do it better than you. And then you can focus on how to sell your drills.
Exactly. So those are commodities, and those aren't things that you're not going to then become if you're trying to make a coffee shop or a tea shop, everything you do is going to be focused on what the user needs, which is a hot cup of tea, or I suppose they like iced tea, cold tea as well. But you are not going to then be producing something that hits everywhere in that value chain, all the way to the power that you need to boil power the stove or the oven or the electric kettle, whatever, and then so you can then pour tea. That's taken care of. Like, you just make sure that you have power, that you pay for your service in your building, and it shows up. And you focus all of your efforts on the user needs, the cups, the ambiance of your tea shop, and the types of tea that you have, and then that you brew them at the proper temperature, and that you have all the varieties that you need, the things that they interact with. And so, yeah, that's kind of how I see it.
Tiani, when you make tea, do you make it with a microwave, a stove, or a kettle?
Oh my goodness. I have never made tea in the microwave, and I never will.
Okay. All of our, both of our British listeners will be very relieved about that.
Indeed.
The American audiences will be confused about how you can make tea without a microwave. It's a question on everyone's lips.
It was even challenging for me to get an electric kettle. It's something about the stove top kettle. It's just, for me, it was just like, but I did recently buy an electric kettle, and I do like it. But no, I have never made tea in the microwave, and I never will. I say never, but that would have to be an act of desperation, I suppose. Like,
whereas we can make this like the UK cut of this podcast, and then we can have in the US edition just like a robotic voice, like in a microwave, obviously. Next question, please.
And it's lifted. Oh, please, no.
Yeah. Nice. That's well. So I'm interested, like, as we sort of get towards the end of this conversation, how did you end up doing this kind of work? Like, what was it about you that attracted you to the technical side and then the systems side? What prepared you for that?
I think partially was, so I think I have a very strange, so the thing that is actually very good about my being exposed to all these different domains of work is also very challenging and frustrating side of the story. My first, I was excited about this job. I couldn't wait. It was flight simulator engineering for United Airlines was the company. And it was Fortran code, which for anyone listening, yes, very old programming language, but it's still in use. And it's actually quite fun to work in Fortran. I found it very enjoyable. A little bit of assembly language and a little bit of electrical stuff, because I had to troubleshoot circuit boards and that kinds of things on the flight simulators themselves. And that was all around the 9/11 time. So I joined before the 9/11 happened. And then they did this kind of totem pole ranking of all the engineers. I was right on the line. And someone decided to retire, which put me above the line, so I was going to stay. And then he changed his mind 2 weeks later and decided he was going to stay. And so then I was off, and I was let go in this layoff that was post 9/11. I kept in touch with everyone, and about 5 months later, they brought me back. They were able to bring me back, and I worked for another year. And then they had a Chapter 11, and the same thing happened, and I was on the bubble again. So
Chapter 11 being
bankruptcy.
America.
Yeah. So
American bankruptcy.
American bankruptcy. And so all of those circumstances all surrounding that time with lots of turmoil in the aircraft industry. And so flight simulator engineering is a very niche job. Fortran is not a very widespread application everywhere, programming language. All of those skills that I put into that, I was just getting started, so I didn't go very deep into my knowledge. And so then I started working different contract work, tried to figure out what am I going to do, and it was partially through that I ended up doing electrical engineering for medical devices, software testing for French language software, since I speak French. Another small flight simulator, building a company that was just kind of starting up, worked for there a little bit. I just did a bunch of different contract work. And so I got to see different workplaces and all, like I said before, but I was always getting distracted after some time of doing that and never kind of feeling like I went deep in deep expertise on one thing. I was sitting back and I started to think why is that happening? What's wrong with these workplaces? Some of the contract jobs I had were interesting, but what's happening with all of the waste? Why is there so much waste? They wouldn't have to lay all those people off. There was less waste, or if we kind of consolidated this thing and we did that. I started noticing things in the system, and I got distracted to the point where if I was working on a product, I was like, yes, this product, we're gonna try to do our best, and we're gonna try to, build this thing together, whatever it was. But I would often say, but we don't have a good chance of doing this very well because we're heavily handing off between 3 different buildings. These people are sitting in cages over here. True story. Cages where they were doing software testing, and the engineers are over in this building. They never sit together.
Cages?
Like a chain link fence cages where I'm not sure why they had cages, but there was they were locked. I think they might have wanted to make sure people didn't steal these satellite TV set-top boxes. I don't know the history, but they sat behind cages.
Sounds like a really high trust environment.
Yeah, so it was different buildings. I was distracted, and then I remember the first time it really hit me that this is something I happened to notice, those in-between things, organizational and systems kind of problem things that I'm yes, we're trying to build this product, but we're not actually enabled to build it effectively, and here's why. And I remember I went into my manager's office and I said, I've figured something out. I was like, this is what's going on. And he was like, okay, humor me. And next thing you know, I'm drawing it on the board, and I've got it looks like a crime scene, string, lines. These people are doing this. Their systems don't talk. They don't ever get invited to that meeting. And it was just kind of he was like, whoa. And I'm over here all of you leaders, isn't this your job to see this and fix this? Because if you fix this, then the thing that you want to happen will be, you've created the conditions now. If you work on some of these problems. And that's the vivid memory that I have of kind of what got me really, really involved and interested in this work. So it was shortly after we learned, we had an Agile coach come in who taught us all, and then some teams were experimenting with new ways of working and Agile ways of working, XP practices, pair programming, and I had some anecdotes about how things were different from before and after with that. And then I ended up moving, and I think I got dropped into the world of consulting. And my first role as a consultant was with ThoughtWorks. And so there, it's the epicenter of pairing and software agility. So I went really deep there. And then from there, built on that into more from the teams and software agility and more just kept building and building more skills in organizational, looking at organizations and techniques for looking at larger systems and the interfaces between teams and that kind of thing. So
there's an interesting pattern there that when it comes to people getting into this agile kind of work. And at the moment, there's I know a lot of people who have drunk the Kool-Aid and yeah, this agile thing's really cool, and they're looking straight away to get into a job as a scrum master or something like that. And they're struggling because you're competing with a bunch of other scrum masters who've been doing it in some way for a long time, or other agile coaches and you don't have the experience of working in that team. And it's everyone that I know pretty much who's got into this kind of work did some agile stuff before they put agile in their job title, right? So it sounds like you did that when you mapped out Charlie from It's Always Sunny in Philadelphia style of the map on the wall with all the strings together. And I had that experience at Cancer Research UK and thinking, this could be working better. Let's get some help in. And you step into that role. And then I'm saying this because I wonder if it would be good advice for those budding Scrum Masters, Agile coaches out there, which is, once you've drunk the Kool-Aid, you've probably got to stay in your job for a little bit and apply some of it as much as possible and work out how to influence for change, how to visualize the system, how to try new practices. And then when you go to that first interview or whatever, you've got some of that stuff under your belt and you're not just saying, well, I've got a certified Scrum Master qualification or professional or whatever. And now I know everything I need to do to get started. You actually have some lived experience.
I would agree. I think that the most important thing is to learn new techniques to help your team, help yourself, help your team with problem solving, visualizing where problems might be, visualizing the workflow. Any team in any organization, whether you have the title of a Scrum Master, if there's a moment where if your team does retrospectives, if your team does planning, there's ways you can introduce different ways of reasoning about and looking at the work and understanding the flow of work, the flow of value. And if you can practice that, that will give you it will get you a long way. My title in that role was like a technical program manager, something like that. And we invited other people to come in and train the organization in Scrum. And then I built a network in the organization of other people who were also doing technical program management or project management. And we kind of built this like community that would talk about our experiences and things we were trying. And that was how I got, the first entry point into it. And I went from that into, having more experience in a very, very bureaucratic environment, going back to the Westrom's typology. And then my first role in consulting was doing this work was at ThoughtWorks. And even then my title was as a project manager. It was as an Agile coach. And there was like some different skills at play that were needed. And yeah, that was, learning by not doing things very well, actually. But there's something
to be said for that, because there's something to be said for learning by not doing things very well, because that is what learning is. Like, there's an error rate when you learn. You have to try something in the wrong context, learn firsthand the perspective of what it feels like to try something and get it wrong, so that next time you try something and get it right. And we have to do that course correction. So I think the only way to do that is get as much exposure to these kind of problems as you can. And that means that waiting for the perfect Scrum Master, Agile coach shaped job or whatever it is can't be the solution, because
it's not.
Or it's an ineffective way of doing it. It means you have to wait a long time before you get those learnings and you gain that wisdom.
That's absolutely right. And there's ways you can, wherever you are, to start getting training, but then also like putting things into practice is more important. And the more you can put things into practice and test them, the greater your knowledge becomes. It moves past just like the book knowledge, and that's what's really, really, really important in this case. I think seeing it in action and getting those insights and seeing the nuances and the struggles of when people are trying to change and trying to do something new, and just that sense of taste and the sense of practice that you get from just trying it.
Yeah. That is a great place to start to wrap up, as I've got two final questions. One is what is one big thing? Is there one thing that you wanted to share or tell this audience about that we haven't had a chance to cover?
We covered so many things. More than I thought we would. Actually, I thought we'd go down more rabbit holes. We actually talked about a lot of different really good topics. anything else I would like to share with the audience? I would like to re-emphasize the idea that we just ended up with on that last thread, which was to try these techniques wherever you are and whatever your role is. And that there are certain people that I've learned, as I stood at that board and remembering that time where I had the string and the connections and I noticed all those things, that there are certain of us that are really attracted to understanding the theory and then putting it into practice, like complexity. And it's connected with the concepts in agility. And you can trace the history of the people who actually came up with the Agile Manifesto and the early experiments they were doing in their respective, fields and then conferences they had been to. And, there's a whole history. So there's complexity and socio-technical systems and theory of constraints and all these things that were created, some time ago. And I've just always go back to them. I always go back to them. And so I guess I would just like to emphasize for the audience that reading up on all of these things that have existed that no one really teaches in school, and you come across them sometimes by accident in business, can be really helpful and can be really foundational to your growth in whatever you want to do, whether it's leading a team as a tech lead, or having your own startup and you want to create this, your job then is to kind of work on the system as the leader, or whether you do want to become a Scrum Master or Agile coach, because that's, what you really enjoy. Those foundational things around, we just mentioned, the theory of constraints and the Toyota production system and Deming's work and Akoff's work and Trist work with socio-technical systems, all of that. It's crazy. All that research has been done. And if you read some of those white papers and books, and it's you feel like they were just written last week. So I think that's another thing that my personal journey has involved lots of digging into all of those things that just exist out there. And my reading list is still too long. I can't keep up, but it's enjoyable. And I always get a morsel or an idea or something that I can take away and then put into practice. So, yeah.
And also that you need to have that side, and then you need to do the thing that we mentioned at the end, which is go and practice the stuff, right? Because everyone's worked with that person that has read everything and doesn't have a practical sort of wisdom about how to implement it, and those people are tricky.
Yeah, you have to read those things, but then learn the techniques or tools or
application.
There's all kinds of applications, and test those. Because otherwise, it just it can be frustrating, I think, for everyone.
Yep, that's true. Where can we find out more about you and your work?
Well, I'm currently working on a website, so you can actually know a bit more about me. Because I've been doing some speaking for the past few years, and I just haven't really I'm not really good at sharing like you are. Don't post enough. But if you want to learn about my work, you can catch me on LinkedIn. I sometimes post on Twitter or Mastodon social. I also am going to be speaking at QCon in London in April, beginning of April. So I will be doing another version of my Agile Cambridge talk, but with a couple of tweaks around patterns and socio-technical systems and all those kinds of things.
Great. Tiani, thanks for joining today.
Thank you so much.
Thank you for listening to my discussion with Tiani Jones on the Agile on the Mind podcast. If you enjoyed this episode and want to receive the Agile on the Mind weekly newsletter, go to agileonthemind.substack.com, and we'll see you next time.